All right, so we're going to take a look at number 1 here. Number 1 says y equals 4x squared plus 8x minus 1. That's a quadratic. I know that because of the x squared. Sometimes it sort of helps if we think about it by writing the standard form with it as we're getting practice of using the quadratic formula. So I might write y equals ax squared plus bx plus c with my equation, so I remember to put everything where it belongs. The next thing I want to talk about is when I look at that 4 is positive. So I know that my graph automatically is going to be opening up. So I like to remind myself of that. I just make a little sketch off to the side. So I go, okay, whatever happens in the end, this parabola should be going this direction, and if not, I need to go back and check. And I'm going to start with the axis of symmetry. That's the first bit of information that we need to get this sketch going. So the axis of symmetry has that formula, x equals negative b over 2a. So if I set this up, I have x equals negative out front. What is my b? My b is 8. And make sure you look here. It's a positive 8. So it's positive 8 over 2 times a, and the a here is a positive 4, so 2 times 4. So therefore x equals negative, well, 8 over 2 times 4 is 8, and 8 divided by 8 is 1, and I want the negative of that, so my x equals negative 1. There's my AOS, my axis of symmetry, x equals negative 1. I'm now going to use this information to find my vertex. So the vertex has the x value of the axis of symmetry because that's what's cutting it in half. So I'm going to go ahead and just plug that back into my other equation. So I have y equals 4 x squared, so negative 1 squared plus 8 times negative 1 minus 1. So we're evaluating. We're taking that negative 1 and we're going to place it or substitute it in for x, and now we're going to solve for y. So y equals, I'm going to do the exponents first, order of operations. So 4 negative 1 times negative 1 is 1. I'm just going to rewrite the rest of my equation. Order of operations, multiplication is next. So y equals 4 times 1 is 4. 8 times negative 1 is negative 8, and I have negative 1 on the end. So I now have 4 minus 8 minus 1, and 4 minus 8 minus 1 is negative 5. So I now have my vertex. My vertex is at negative 1, negative 5. Next on the list, I need a y-intercept. Now we know that when we're looking for a y-intercept, that the x has to equal 0 for a y-intercept. So I'm just going to plug 0 in for x. So I'd have y equals 4 times 0 squared plus 8 times 0 minus 1. Now anything times 0 is going to be 0, so the first term is going to be 0, the second term is going to be 0, all minus 1, so y is going to equal negative 1. Therefore, my y-intercept is 0, negative 1. And that's a lot of information. We have an axis of symmetry, we have a vertex, and now we have our y-intercept. And next, we're going to start graphing this. So I'm going to go ahead, you don't have to make a huge graph. Think about the numbers you've been given and work with that. So you don't have to show a graph that goes from 10 to 10 or 20 to 20. It's however you want to set it up. You are welcome to, but we can kind of think through this. And these are all negatives. So, but I know it's opening up. So I'm going to start with my axis of symmetry at negative 1. So I know that my axis of symmetry is going through negative 1. My vertex, and I'm going to go ahead and label that, x equals negative 1. My vertex is at negative 1, negative 5. So I'm going to negative 1, negative 5. 1, 2, 3, 4, 5. Should be right here. I'm going to go ahead and label that, negative 1, negative 5. My y-intercept, though, is at 0, negative 1. So my y-intercept is here. And this is where we get that third point. Remember, this U is symmetric. So we know that if there's a point on the right-hand side of the axis of symmetry, there has to be one on the left-hand side that maintains symmetry. So it's going to have the same height. So if it's at -1, the other point will be at -1. And how far am I from here to here? Well, I'm 1 unit, so that means I need to go 1 more unit over here. So my point here would be -2, -1. And with 3 points, we can draw a fairly decent parabola. So again, the steps. Find your axis of symmetry. Find your vertex. Find your y-intercept. Use that information to graph half of your parabola. And then use symmetry to create the third point that makes a perfect U. Don't forget, this is where we'd want to go to Desmos and check that as well. So we would just type it in, make sure that our graph matches in with Desmos.